Math is a wonderful thing. Math is a really cool thing.
Alright, let's try to solve the following problems. Again, we are still using substitution. If you look at this problem, we can either solve for x or y, but I don't really recommend solving for x for either of the equations. Why? It's because if, for example, in equation number 1, when you solve for x, you will have 3x plus y equals 9. When you subtract y to both sides, you will end up getting negative y plus 9. And then you are going to divide 3 to both sides, and then you will get a fraction or a denominator. Okay? And it's kind of hard to plug in an expression having a denominator. It will complicate your solution. Same thing with example or equation number 2. I don't recommend solving for x because you will end up getting 1/2 as a coefficient of your y. So here we can solve for y either in our first equation or in our second equation. So let's just try solve the y uh, variable in our first equation. So from our first equation, you will have 3x plus y equals 9. Subtract 3x to both sides, you will get y equals negative 3x plus 9. Then I'm going to use this value of y and plug it in to the other equation. Alright, so we will have now 2x minus, now remember, the entire y is being multiplied by negative 1 or by negative. So I am going to put a parenthesis here. So I will have here negative 3x plus 9. Remember, that's the y value from our first equation equals 1. So you will have 2x. Now distribute the negative sign. So negative times negative 3x, that's plus 3x. Negative times positive 9 is negative 9 equals 1. Let's solve for x. 2x plus 3x is 5x minus 9 equals 1. Add 9 to both sides, we'll get 5x equals 10. Divide by 5, we will get x equals 2. Once you have a value for one of your variable, you can either use the first equation, second equation, or this equation that was derived from the first equation to solve the value of y. In this case, I am going to solve this equation since my y has been already solved. So I will have y equals negative 3x plus 9. But the x that we got earlier was equal to 2. So you will have y equals negative 6 plus 9. Simplify, you will have positive 3. So your answer, the intersection of these two lines, will be the point 2 comma 3. And of course, don't forget to verify your answer. So let's plug in.
So x is equals 2, so 3 times 2 plus y is equal to 3. Is this equal to 9? So 3 times 2 is 6, plus 3 is indeed equal to 9. So the first equation gave us a true statement. Let's check the second equation. 2 times x, again x is equal to 2, minus y is equal to 3. Is it equal to 1? 2 times 2 is 4, minus 3 is equal to 1.
Alright, so there we go. We were able to find the solution. We have 1 point, so we have only one solution, and we also verified our answer. Okay, next problem. Now in this system, note that the only variable that has no coefficient is x, and that will be your hint. It means that the best way to solve this using substitution is to solve for x in our first equation. Why? Because, for example, if you solve for y in your first equation, you are going to divide by 5 later on. And whenever you divide, there's a possibility, well, in this case, you will have a denominator of 5. So I don't recommend having a denominator when you solve substitution. Same thing with your second equation. When you solve for x, you are going to divide by 12 later on, and then you will have a fraction. If you solve for y in your second equation, you will divide by -5, and you will end up getting a denominator. So let's just solve x from our first equation. So you will have x plus 5y equals -20. So subtract 5y to both sides. You will get x equals -5y minus 20. So this is now the value of my x from my first equation. We are going to use this value of x and replace the x variable from the other equation. So from our other equation, from the second equation, we will have 12 times x, which is -5y minus 20. So I'll replace now my x here, -5y minus 20. And I'll just bring down everything. Minus 5y equals -45. So distribute 12 to -5y. You will have -60y. 12 times -20 will be -240 minus 5y equals -45. Combining like terms, -60y minus 5y is equal to -65y. So bring down everything, -240 equals -45. Add 240 to both sides. You will have -65y, 195. Alright, next we divide by -65 to both sides. So divide by -65, divide by -65, and we are going to get y is equal to -3. Once we have a value for one of the variables, in this case I have a value for my y, I can either use the first equation, second equation, or this equation to solve the x variable. Now I'm going to use this equation. So I'll just replace y by -3 times -3 minus 20. So -5 times -3 is positive 15 minus 20, and we are going to get -5. So our answer is -5 comma -3. I have 1 point, so this is the point of intersection of these two lines. So we are going to say that we have here one solution. Okay, let's verify our answer. Let's check. X equals -5.
My y is equal to -3 equals -20. So we are going to verify if the two sides are the same. So 5 times -3 is actually -15. Then add a -5, it will be equal to -20. So the first equation is correct. Let's check the second equation. 12 times x. My x is equal to -5 minus 5 times y, -3 equals -45. Okay, so let's simplify this side of our equation. So we have 12 times a -5, which is actually -60. And then I have here -5 times -3 is positive 15. So we're going to add 15, and we are going to get a -45, which is actually the one that we have on the right side of this equation. So
the second equation is also correct. Therefore, we know that our answer -5 comma -3 is correct. Practice question number 3. If you look at this system, my y here has a coefficient. My x here has a coefficient of -2, so I will not solve either x or y in our first equation. Now, in our second equation, my x has a coefficient 2, so I will not solve x here. Well, we can solve a variable that has a coefficient provided that after we divide and simplify and isolate that variable, we will not have any fraction. As much as possible, we don't want to deal with fraction. Alright, look at this. Y has no coefficient, so I will solve my y here. So, to solve for y, I'll just subtract 2x to both sides, and we will have y equals -2x plus 9. Okay, so once I have the value of my y, I can now replace the y variable from the other equation, meaning from our first equation. So I will have 3 times y, which is negative 2x plus 9. So negative 2x plus 9 minus 2x equals 11.
So when you distribute, you will get negative 6x. 3 times 9 is 27. Minus 2x equals 11. So combining like terms, I will have negative 8x plus 27 equals 11. Subtract 27 to both sides. We are going to 16 negative. So negative 8x equals negative 16. Divide by negative 8. X is equal to a positive 2.
Once we have a value for our x, we can go back here and solve y. So we will have negative 2
times x. Our x is 2, so plus 9. So you will have negative 4 plus 9 equal to a positive 5.
So the answer that we got here is 2 comma 5. We have one point of intersection, so we have here one solution. Next, let's verify our answer.
So 3 times y, our y is 5, minus 2 times x is equal to 2. Is this equal to 11? This is 15 minus 4, which is actually equal to 11. So the first equation is correct. Let's verify the second equation. My y is equal to 5 times 2, well, plus 2, and then x is equal to 2. So 2 times 2, is this equal to 9? 2 times 2 is 4, plus 5 is indeed equal to 9.
So there we go. We know that this point satisfies both equations. Our example number 4. Okay, if you look at this system, my y here has no coefficient. My y here has also no coefficient. So I will rather either solve for the y in my first equation or the y in my second equation. So let's go ahead and solve the y in our second equation. So here I will just add 6x to both sides. We are going to get y equals 6x minus 2. Okay, so this value of y came from the second equation. We are going to use this and plug in to the other equation, which is the first equation. Now, if you have a minus sign before the variable that you are going to replace, make sure that you put a parenthesis. So we have 6x minus y, but remember, y is equal to 6x minus 2 equals 2. So now, let's distribute our negative 1. So negative times 6x is negative 6x. Negative times negative 2 is positive 2 equals 2. 6x minus 6x is 0. And we will end up getting 2 equals 2, which is actually a true statement. Since we have here a true statement, we are going to say that we have many solutions. Turn out that the first equation is actually the same as our second equation. If you are going to write this in the slope-intercept form, you are going to get y equals 6x minus 2. Similarly, in our second equation, we're writing this into the slope-intercept form. You are going to get y equals 6x minus 2 also. So actually, we will have here two coinciding lines when you graph these two equations. Therefore, we will have here many solutions.
Math is a wonderful thing. Math is a really cool thing.